So the first thing we're going to talk about is the zero product property. This is a property that you guys probably know, maybe you haven't really explicitly have written out. But essentially what it says is that if I know two things that are multiplied together are equal to 0, then either the first thing is equal to 0 or the second thing is equal to 0. And we use it a lot when we're factoring because it allows us to solve for x once we have all of our individual factors. So in this question, we have something that's already been factored. We have something that would result in x minus 3 times 2x plus 5 is equal to 0. And now I can use the zero product property to set each part equal to 0 to solve for x. So set the first factor, x minus 3 equal to 0. Pretty easy to solve that guy. I add 3 to both sides and I get the result that x is equal to 3. Now I can do the same thing with my other factor. 2x plus 5 is equal to 0. The problem solving process is a little bit more complicated, but it's not super difficult. I would subtract 5 from both sides. I'd get 2x is equal to negative 5. Then I would divide both sides by 2, giving my result of x is equal to negative 5 halves. Now, this section is really going to focus on a lot of different ways to solve quadratics. A quadratic is something that has x squared or y squared, something to the second power in it. So this is the first 4 minutes called simple factoring. It's not an ideal term for that because, I mean, factoring isn't the most simplest thing in the world, but of the methods that we're going to see, this process is definitely the least involved. And so in order to do simple factoring, what we have to do is we have to have 0 on one side of the equation. So if I'm going to try and factor this equation that I have, x squared plus 5x is equal to negative 6, then I add 6 to both sides, and I get 0 on the other side. So eventually when I get done with the factoring, I can use the zero product property and solve. Now to factor in the simplest form, what I do is I look at the last term, the term that doesn't have an x in it, and I look at my middle term, the term that has an x but not x squared. And I want to find two numbers that multiply to get me the last number, in this case 6, and add to get me the middle number, in this case 5. And it's usually easiest to kind of look at the multiply part of the equation because there's only so many things, or at least so many nice things, that can multiply to 6. So when I think about this problem, I think, okay, what multiplies to 6? Well, 1 times 6 does, but that doesn't add to 5. 2 times 3 gets me 6, and 2 plus 3 gets me 5. And so I've kind of solved the problem. I've guessed and checked and figured out what two numbers multiply to get me 6, add to get me 5. And so then I just rewrite my thing in factored form. My factored form will be a parentheses. It'll be, the fancy name's a binomial, but it'll be x plus my first number, which is 2, and x plus my second number, which is 3. So x plus 2 times x plus 3. Order doesn't really matter with factoring. So you could also write x plus 3 times x plus 2 is equal to 0, and that's perfectly fine. Well, now using the strategy that we talked about on the previous slide, we set both parts equal to 0 and solve. In this case, it's a one-step process, so I didn't really write it out explicitly, but I would subtract 2 from both sides. I get x equals negative 2. And I would subtract 3 from both sides and get x is equal to negative 3. Now, checking your answers is a very valuable thing throughout this course, and if you wanted to, you certainly could in this case. You would take those numbers, plug it back into the original equation, and then if you follow order of operations, you should get a negative 6 on the left side and a negative 6 on the right side, and that should work for both of these answers. If they don't, you might have made a mistake, maybe picked the wrong things when you're factoring. Definitely worth looking into, especially as we start to get into more difficult examples. Okay, now a more involved process is factor by grouping, and although it does have a lot more steps, it always works when we're factoring, where the previous method, the simple factoring, only works if, we see this equation up top, if there is no a. So if we see something like this equation, 4x squared minus 13x plus 3, I can't just use simple factoring on it because I have something in front of my x squared. In particular, I have 4. So I'm going to use this method of factor by grouping. My first step is I multiply the first term and the last term. So I multiply the 4 by the 3. And I'm going to kind of organize my information over here. So 4 times 3 is 12. I'm going to make an x. You don't have to make an x. I just found that helpful when I've been teaching this course to organize my information. So I'm going to put the 12 on the top part of my x. And then I'm going to put that middle term of my equation, the negative 13, I'm going to put that on the bottom of my x. And now I play the same game that I played on the previous slide. I want to find two things that multiply to get me 12 and add to get me negative 13. Well, I've obviously done this problem before, but that might take you some time. Eventually, hopefully, you'll be able to guess, well, negative 12 times negative 1 gets me 12, and negative 12 plus negative 1 gets me negative 13. Now, what I'm going to do is I'm going to rewrite my equation with this new information. In particular, I'm not going to change the first term at all. I'm not going to change the last term at all. I still have my 4x squared. I still have my 3. I'm going to change my middle term. So I broke up my middle term and I took that negative 12 from that big X on the top right. And I took the negative 1 from that as well. And so I'm going to rewrite my equation as 4x squared minus 12x minus 1x plus 3 is equal to 0. Now, where the title comes from, the factor by grouping, is at this point I'm going to group the first two terms and I'm going to group the last two terms. And after I've done that, my goal is to now figure out what fits into both of those first two terms, only those first two terms for starters. So I look at that, I have 4x squared and I have negative 12x. Well, the biggest number, and we need to find the biggest number that fits into both of those is 4, and x fits into both of those terms. So what I would do is I say, okay, well, 4x fits into both of those terms. I'm going to divide both terms by 4x. And so that first part now becomes 4x times x minus 3. 4x squared divided by 4x gets you x. And negative 12x divided by 4x gets you negative 3. And now I'm going to repeat the process for the next group, that negative 1x plus 3. Now you might be thinking, well, there's no x's in both terms, so I can't factor out an x. And there's really no number bigger than 1 that fits into both of them, so I can't really do anything with that. But one cool feature of a factor by grouping is that if you're doing everything correctly, then your two factors in this step that we're on right now need to match. And so my first factor, I have x minus 3. I want to make it so I have x minus 3 in my second, and I currently don't have that. So to resolve that, I'm going to pull out a negative 1 out of both terms. And by pulling out, and I should have said this in the first thing, I'm dividing both terms by negative 1. So I go ahead and do that, and I put the negative 1 in front, and then negative 1x divided by negative 1 gets me x. 3 divided by negative 1 gets me negative 3. And now notice here I have matching. That's the goal. If you're not matching in this step, you did something wrong. Maybe you didn't pull out a big enough factor above, or maybe you needed to pull out a negative, or maybe you didn't pick the correct factors up in that big X that we had, the negative 12 and the negative 1. So that's a nice little checkpoint. And so since they are matching, we did it correct, or we probably did it correct. And so I look at the two terms in front of my groups, so the 4x and the negative 1, and that becomes one of my factors. And then my other factor is the thing that matched up, my pair. I have my pair of x minus 3's, and so that's going to be my second factor. And now I have my factored form, 4x minus 1 times x minus 3. And if I wanted to check with the factoring at this point, I could multiply that back. I would get all the way back to the start of my problem. So now I'm going to use, again, the zero product property to solve. I'll set the first factor equal to 0 and the second factor equal to 0. Solve the first one using some basic algebra. I add 1 to both sides. I get 4x is equal to 1. Divide 4 from both sides. I get x is equal to 1/4. And then the next equation is a one-step problem. I just add 3 to both sides and I get x equals 3. Now, well, the title of this section is quadratic equations or quadratic functions. So if you see a question like this, you might think, well, okay, now I do have an x squared, but I have an x cubed. I have something bigger. And this is called a cubic. And so to kind of deal with that, we're going to use a similar idea, similar concept. We're going to move everything to one side. We're going to get a 0 on the other side of the equation. Now, ideally, it would be nice to make this or turn this into a quadratic, because then we could use the strategies we've seen on the last 2 slides. Well, we can actually do just that by taking out the greatest common factor, which in this case is x. I can pull an x out of all 3 terms. So I would divide each term by x. Well, x cubed divided by x becomes x squared. Negative 2x squared divided by x gets me 2x. And negative 3x squared divided by x gets me negative 3. And now I have a quadratic inside of the parentheses. So I'm still going to solve for x eventually, but now I'm just going to solve for my x squared minus 2x minus 3. Well, I guess I solve for it immediately in this question. So I know x is equal to 0 is still one answer. And so to find my other x's, I'm going to take that stuff inside the parentheses, and then I'm going to factor it again. And this one is kind of a nice simple factoring question. I'm going to look for 2 things that multiply to get me negative 3 and add to get me negative 2. Well, negative 3 times 1 gets me negative 3. Negative 3 plus 1 gets me negative 2. Those are my 2 factors. I set them each equal to 0 and solve. So I get the result x equals 3 and x equals negative 1. So I get 3 answers. Now we're going to kind of pivot a bit, and we're going to go outside the world of factoring. And factoring is very, very valuable. We're going to see that time and time and time again throughout this course. So if you aren't comfortable with any of those methods I just showed, I'd recommend kind of reviewing them, doing the practice problems now, so you feel confident with them. But instead, we're going to kind of focus on something else. And so in order to build up to those concepts, we're going to talk about just the idea of square roots. So if I have this equation right here, x squared is equal to 4. In order to solve it, I need to undo the square. Well, when we're undoing the square, what we do in mathematics is we square root both sides. So we will get x is equal to 2. Square root of 4 is 2. But that's not the only answer that works. There's another number that if I multiply it by itself, I would get 4, and that number is negative 2. So to account for this, when we're solving equations with squares, if we take the square root of both sides, what we need to do is we need to say, okay, I can have a positive value, or I can have a negative value. So to kind of see that in practice, I skipped ahead a little bit on the right side here. I'm going to solve this equation. If I'm going to solve a square root and I don't have a trinomial, or I don't have extra x's flying around, I'm going to try and get everything to one side and leave the x squared on the other side. So in this case, I'm adding 50 to both sides. I'm going to divide both sides by 5. I'll get x squared is equal to 10. Well, now I'm going to use what I learned from the previous problem. I'm going to square root both sides, but I need to make sure to account for the fact that I can have a positive answer or I can have a negative answer. So I'm going to put a plus or minus in front of my square root. And you should be doing that anytime you're square rooting in this course, is you should think, if I'm solving, I need to put a plus or minus in front of my x. Now, if that was a nice number, if that was a square root of 16, I would find the actual answer. But it's square root of 10. We could get an answer in your calculator. It's going to be some weird heavy rounding thing. I honestly prefer you just leave that as x equals plus or minus 10. Okay, so sometimes we can't go immediately into factoring. We have to do a little bit of work first. So that's the case in this example. So I have 4x squared equals 15 over 2x plus 1. So there's a couple of issues making it difficult to factor this equation. And one of those issues is that I don't have 0 on one side. And the other issue is that I have a fraction. And that second thing is not really an issue if you are super good with fractions, but I would not classify myself as one of those people that is super good with fractions. So it would make my life easier if I wouldn't have to deal with fractions. And so we can get rid of a fraction, or in all honesty, every fraction in our question, if we multiply by a certain number. And that certain number is the LCD of every fraction in your equation. Now in this case, I only have one fraction, so my LCD is just 2. If I have more than one fraction, I might have to do a little bit of work. And so since my LCD is 2, what I'm going to do is I'm going to multiply everything by 2. And I'm allowed to do that. multiplying one side, and then I'm multiplying the other side, so I'm not really breaking any of the rules of equality. And so if I do that, then I get 8x squared is equal to my 15 halves just cancel to get me 15. And then I'm left with 2. And it's very important that I multiply everything by 2, not just my fractions, not just my variables or my terms with variables. I need to multiply everything by 2. And now I'm going to move everything over so I have 0 on one side. So 8x squared minus 15x minus 2. And then I set that equal to 0. And now I can go into factoring. So I'm going to use factor by grouping since I have something in front of my x squared. And additionally, since it's probably a good idea to practice this one more time. So I do 8 times negative 2 gets me negative 16. My middle term is negative 15. So I want to find 2 things that I can multiply to get me negative 16, add to get me negative 15. Well, those 2 things are 1 and negative 16. So I break up my middle term, like we've seen a few times before this, to negative 16x plus 1x. I group the 2 things. And then for my first 2 terms, I try to find my GCF, the thing that fits into both of them. And that thing is 8x. So if I divide both of those terms by 8x, I'm left behind x minus 2. And then for my second 2 terms, I don't have a greatest common factor, or more accurately, my greatest common factor is 1. And so I'm going to pull out a 1. And now I have that matching, those 2 matching factors, which is kind of the goal of factor by grouping, or it's certainly a very good checkpoint for factor by grouping. And so my 2 factors are going to be the things in front of my matching factors. So 8x plus 1 times my matching factor, x minus 2. And then kind of the big new thing in this section is now we're actually going to solve for x. So I set both parts equal to 0 and solve. 8x plus 1 equals 0. I subtract 1 over, divide by 8. And then the other one is x minus 2 is equal to 0. So I just had the 2 over. So I actually didn't write that one out. I probably should have, but my other answer is 2. Now to get into an application problem, and this is a pretty popular type of application problem because it deals with quadratics, and it is like a real problem you would see in a physics course. You deal with kind of projectiles all the time, and projectiles are very nicely modeled by these quadratic equations. So in this case, I have this formula, h is equal to negative 16t squared plus 96t, and I should have said what h means and what t means, because otherwise I'm not really giving you a good formula. T is going to be time, I believe it's in seconds, and h is going to be height, and I believe the units for that are feet. So h is my height, t is my time. Now the question is, when will the rocket hit the ground? I'm going to pause for a second and let you think about that. What does that mean? What will the height be of my rocket when it hits the ground? So this kind of falls into one of those almost, I think duh might be a little bit insulting, but it's one of those that once you see it, it's, oh, okay, I get it now, but it's a bit of almost a riddle until you get there. And that's, the height is 0. If it's on the ground, it's not above the ground at all. There's no distance between it and the ground, so I know my height is going to be 0. So I rewrite my equation with 0 in for my h, and now I'm going to solve for my t. And so now we're no longer kind of dealing with a word problem. We've built our equation, and we're just doing something that we've done in this section. We're going to factor and solve for t. Now there's a couple of ways to factor this. There isn't really a wrong way, but I would recommend starting by factoring out the GCF completely instead of trying to deal with kind of a confusing factor by grouping with very large variables or coefficients flying around. And so looking at both of those, I see t fits into both terms. I see 2 fits into both terms. I believe 4 does as well. In fact, 8 does, but I'm looking for the greatest common factor. So the biggest number that fits into 16 and 96 is 16. And I pulled out a negative 16t. You could have just pulled out a 16t it's fine. Your equation might look a little bit different from mine, but either way, you're going to be able to solve for your two answers. So I don't know why I decided to do negative 16t. I guess that makes the binomial, the t minus 16, look nice, but you don't have to do that. So now that I have that factored out, I have two different factors that I can set to equal to 0 and solve. My first one is negative 16t is equal to 0, so t is equal to 0. And then my second one is t minus 16 is equal to 0. And so I add 16 over and I get t is equal to 16. Now, once we're kind of done doing the math, usually, honestly, almost always with a word problem, you look back at the problem and think, what is the question actually asking me? Did I get the right answer? And if not, do I need to go further, or do I need to state it more clearly? So in this case, the question was, when will the rocket hit the ground? And so I do have two solutions, and actually two solutions make sense in this case because there's two times when the rocket is on the ground. One of them is when I haven't shot it off the ground, and then the other is when it hits the ground. So t equals 0, although it makes sense, isn't what the question's asking for. It's asking for when it's going to kind of return to the ground. And so then the correct answer is t is equal to 16. And as I mentioned, this is pretty poorly written question, but if I rewrote it as kind of the specifications where I said h is height in feet and t is time in seconds, then it's going to hit the ground in 16 seconds, which makes sense if this is kind of a model rocket, like a toy rocket, not a real rocket. Hopefully it doesn't take 16 seconds for a real rocket to hit the ground again.